All right, let's dive right in. We're going to talk about something foundational to networking, the OSI model, and explore how it's being completely transformed by artificial intelligence. It turns out, this old framework has become a map to a new kind of digital battlefield, with skirmishes happening at every single layer of the network stack. So let's see just how deep this rabbit hole goes.
So, you have to ask the question, right? Is a networking model that's what, 40 years old, from the era of big hair and cassette tapes, still relevant today? I mean, in the age of generative AI and systems that think for themselves, it's a totally fair question. And the answer, maybe surprisingly, is a huge yes. It's actually more critical than it's ever been. But it's not just some static diagram in a textbook anymore. Today, you've got to think of the OSI model as the essential map for this new, invisible war, where both the attackers and the defenders are arming themselves with AI.
Okay, so for a real quick refresher, here are the 7 layers. You've got application, presentation, and session up at the top. That's all about the data we actually see and use. Then you've got transport and network, kind of the core of how data gets from A to B. And at the bottom, data link and physical, which is all about the actual hardware and wires. We're going to march right down this stack and see where AI is making its mark. So let's start at the very top. We're going to group layers 7, 6, and 5 together: application, presentation, and session. This is where we, as humans, actually interact with everything. And it's probably the most visible front in this whole AI cyber conflict, because it's literally where human-generated data and AI-generated data smash right into each other.
So the first big threat is something you've probably already seen. You know those old phishing emails with the terrible grammar? Yeah, those are a thing of the past. AI can now scrape your social media, your company's website, and generate millions of perfectly tailored, contextually aware phishing emails. Your classic email filters, they just don't stand a chance.
But here's where the AI arms race really kicks into high gear. To fight these AI-generated threats, we now have AI-powered defenses. For instance, a web application firewall, or WAF, think of it as a shield for web apps, can now use a large language model to see a brand new attack and automatically write a rule to block it. We're talking minutes, not days. It's AI versus AI, playing out in real time.
And AI isn't just playing defense. It's making our code more secure from the very beginning. When you use generative AI to scan code for bugs, it doesn't just look for patterns. It understands the context of the code. And the result is pretty staggering: a 40 to 60% drop in false positives. That means security teams can stop chasing ghosts, and developers can focus on fixing the real problems.
Now, as we drop down into the presentation and session layers, AI is still right there in the fight. At layer 6, it can spot fake security certificates just by noticing tiny anomalies that a human would never catch. It can even identify malware talking to its command and control server, even through encryption, by looking at its TLS fingerprint. It's like a digital signature that gives away the connection, even if the content is hidden. Then at layer 5, AI uses behavioral biometrics, your unique typing rhythm or how you move your mouse, to make sure your session hasn't been hijacked.
Okay, let's move down into the core of the network. We're talking the transport and network layers. Here, the game is all about massive, massive scale and just blinding speed. This is where AI has to manage incredible volumes of traffic and make decisions in a split second.
And down here, the threat level really ramps up. Attackers are now using AI to orchestrate DDoS attacks that are smarter than ever. An AI-powered botnet can hit you with one type of attack, and the second it sees you blocking it, it'll instantly pivot to a different attack vector, constantly probing for a crack in your defenses, all in real time.
So how in the world do you defend against that? Well, with an even smarter AI, of course. Machine learning models can now analyze network traffic and actually predict a DDoS attack before it even causes an impact. That triggers a totally autonomous response. All the traffic gets rerouted to these huge global scrubbing centers, the bad traffic gets dropped, and only the clean, legitimate traffic makes it to its destination.
And this really shows you the cat and mouse game at play. An attacker's AI can now map out a network so quietly that its activity just blends in with all the normal noise. The only way you can possibly catch it is with a defensive AI that has spent weeks just learning, building a behavioral baseline of what normal traffic looks like for you. That way, it can spot even the tiniest, most subtle deviation.
All right, let's take this all the way down to the wire. Layers 2 and 1, the physical foundation of the entire network. We're talking switches, cables, the actual hardware. You might think AI has no place down here, but you would be very wrong. This is where the threats get, well, they get pretty wild. Think about this.
Nation-state actors are using AI-guided robotics to install tiny malicious hardware implants on motherboards during the manufacturing process. These are the kinds of supply chain attacks that are almost impossible to find once that hardware is sitting in a data center.
So the defense, again, has to be just as smart. AI-powered computer vision can watch thousands of CCTV cameras in a data center at once, spotting things a human guard would miss, like someone accessing a server rack who shouldn't be. And here's the magic. It links that physical event to a digital response. A rogue device gets plugged in, and the AI can instantly shut down that network port and revoke the user's credentials, all in less than 3 seconds.
So we've traveled all the way from the application you use down to the physical wires. And what we're seeing is a completely new reality for network security. This is just the beginning. To really get a handle on the future risks, we need to look at the whole picture we're facing today.
So let's recap. At the very top, you've got hyper-personalized phishing targeting the human being. In the middle, you have these adaptive DDoS attacks hammering the infrastructure, and stealthy recon that just hides in plain sight. And at the very bottom, you have physical supply chain attacks that compromise the hardware before it's even powered on.
So what's the big takeaway here? The crucial point is that the OSI model is no longer a simple map of how data flows. It's a map of a multi-front war. This arms race between AI attackers and AI defenders is happening at every single layer, all at the same time, and it is accelerating every single day.
And that leaves us with one final and pretty heavy question. As all these autonomous AI systems are fighting each other up and down the network stack, making decisions in microseconds, who or what is really in control of our digital world anymore? The answer is becoming less and less clear. Thanks for watching.